Hi guys, this is the second portion of 6.4. So we're going to talk a little bit about compound interest and then also exponential change and how to set up those particular questions. Okay, so a couple of reminders, and this may look a little different than what you did um, back in like Algebra 2 or something. This formula is the same formula as one you learned that was A equals P, which is the principal. The way this looks just means initial amount. So that A sub 0 always means initial. That means what you started with. And then 1 plus, you used to know it as the rate over N. N was the number of times a year. And in this particular text, they just say K, which is still the number of times a year. So if that is annually, that's once a year. Semi-annually would be twice a year. Quarterly, 4 times a year. So just plugging it in and using that correctly. And then it used to be NT. And so what we're going to do is we're going to give you parts of this and have you solve for different things that are maybe not given to you. All right. And then the next one, the difference is this first equation where it says N, that means how many times a year something, I'm sorry, the money is compounded. And so what happens with a compounded continuously is the formula looks like this. Again, you knew it as the PERT formula back in the day, and where P stood for the principal, or like we said, the initial amount. And then E is just the constant, and then 2 the rate times time. And that's the same thing. It just means it's being compounded every single second of every single day. Yeah, we're going to do a few examples. These are going to go along with your homework. So take good notes, take your time, stop and play as you need to. These are going to go, I'm going to do 16 with you, and then you're going to do 15. I'm going to do 20, and you're going to do 19 in your homework. All right, so number 16 is a compounded continuously, and they give us some information about this. Now, I like to use the old school formulas just because I do teach Algebra 2, and that's what I'm used to using. I don't care which one you use as long as you know what the variables stand for. And what this says is that we have an initial $2,000. And the first bit of information that we know is that it takes 15 years to double the amount. So if I'm doubling the amount, then my final amount is going to be 4,000. My E is constant. The rate is what I'm looking for, and we said it takes 15 years. So that would look like this setup. And so when I divide by 2, really this kind of makes sense because you're going to be doing 2 times the principal is what you're going to end with. So this kind of makes sense that it should be set up that way. And that will save you some time later when you get to questions that cut it in half and things like that. All right, so what do we do at this point then? Now it's just a basic solving exponentials. So I have natural log of 2 equals my natural log and E cancel out. And then I'm left with 15R. And this gives me a rate of 0.0462, which is actually from a decimal to be 4.62%. All right, so I'm going to use that information to answer the second part because all that answers is the annual rate. And then the last one says, I want the amount that I'm going to have in 30 years. So now that I have a rate, I can set this up and find that out. I'm still starting with $2,000. But now I know that that rate is, I'm going to use 0.0462, and I want to know the time that it takes to do that. Okay, so I will enter that. No, I'm sorry, it's 30 years. So the time is 30 years. I want to know what I have left after that. All right, so once I solve that, and you can practice it in your calculator, let me know if you have any trouble. If you round this off, like 0.0462 times 30, E that and multiply by 2,000, you're going to get something like 7,997. But that's because it's rounded off. If you actually use the full decimal that you get over here when you're dividing and use that full exponent, then it actually comes out to a nice rounded 8,000. Okay, now I know when I'm looking at these and grading through them that if you round off, then it's going to have a problem like that. Okay, so anyway, that is what you're going to do to help you with number 15. Now, number 20 has 4 parts to it. So you're going to first start out with A says we're going to work this annually. And so, again, we have $2,000 to invest. We want to know the amount of time it takes to double if we are doing this annually and we have a rate. Okay, so we're going to set up for number 20, we're going to double that amount again. I don't know what's going on with my pen here. But this is in times per year. So we're going to use it, we're going to take our rate, which is going to be 0.0825, and divide that by annually would be once a year. So this is kind of like 1 times t, where t is what I'm looking for. And then so when we solve that, let's do this really quickly. Okay, this is kind of what we're looking at after we simplify. Now we're going to natural log both sides. And what that does is it drops my t down, if you remember the power rule. That's the whole point in doing that. And now t is about, what did I get there? 8.74 years is how they're reading that. 8.74. Okay, so let's see, part B works the same way, except this time we're working this monthly. So we're going to make our N or our K in the other formula, we're going to make that 12. So the setup of this is going to look a little bit different. I'm going to go ahead and jump down to where we divided by 2,000 on both sides. And it would actually look like rate's still the same. And we want that this time over 12 because it's a monthly. And then I'm going to leave the solving part of that to you. So you can just kind of pause the video, try that on your own, and then just make sure you're getting 8.43. And if you can't, try it a couple times and then let me know and I'll try to help you if I can. Okay, C is the exact same thing except this time it's quarterly. So our setup is going to be very similar, except for quarterly, we're going to use 4. And again, that would be to the 4t. Solving that, you're going to get about 8.49. Alrighty, and then the last question is going to be very similar. The part D that's on there, it's going to be very similar. I am running out of room, so I'll try to do this over to the side. It's pretty easy anyway. This one's now continuously. So you're going to take the same amount of money and we want to double it. So it would look like 2 equals 0.0825 e to the t, there we go. And now we're going to natural log both sides, and that's after I've set up using the compounded continuously. I think you can figure that part out on your own. And then we're going to take natural log of 2 and divide that by 0.0825, and that should give you 8.4. Okay, so use that to help you with that part of your homework. Now we're going to move on to exponential change and what the setup of that looks like. And really it's not that much different than the compounding continuously formula. Your y sub 0 is just going to be your initial amount still. Y is what you end up with. K is going to be some constant of growth or decay. So if you notice here, if K is positive, then that's going to be a growth. If it's negative, then that will be a decay. So really what you're noticing is that this is just a really good reminder of some things that you did in your last classes, whether that be Algebra 2, Pre-Calc, wherever you came from. All right, so what I want to look at with you is on page 22. Let me get there. Number 22 on page 357. Again, this is going to help you be able to do homework on number 21. Okay, so what they're doing is they're giving us a setup, and we're going to use our separation of variables to work with this one. And so what we're looking at is a function dy dt equal to negative ky. Now our job here is going to be to solve for k. All right, so we don't have a whole lot of information other than we have a half-life and that it's for 65 minutes. Okay, so what we're going to start doing is separation of variables. I'm going to go ahead and drop this negative because we're just solving for k anyway. So whatever we get for k is going to end up being negative in the end because it's a decay, because it's a half-life. So obviously it's decaying. Okay, so what we're going to do is bring our y over to this side. We're going to leave our k and then multiply by dt. Okay, so that's going to give us the natural log of y. Oh, I'm sorry, once we integrate, we have the natural log of y on the left, and then kt, and then we remember are just trying to solve for k. So if we know that our time is going to be 65 years, let's just say that if this was 65, we're going to be dividing by 65. And then we wanted our final amount to be half of what we started with. So this y value is really just 1/2. So this will be the natural log of 1/2 over 65. And that is equal to k. Okay, so that's how your answer will be left also in the ones that you're solving. Let's look at two really easy examples here to go along with that idea. Number 12, just kind of basically all they want you to do is set up what the function is. So we're going to start with, we're going to call our function y of t. The y of 0 equal to 200 just means that's your initial amount. So we're starting with 200 and we want that we want the decay to be negative 0.5. That's it. That's all they really want you to do for those. So when you do 11, I don't want you to get confused. That's really all that they want you to do. Okay, now 14 is a little bit different. We don't have the same amount of information. We do know the original amount, so we can start with that. The original here is 60. And we're just going to set it up originally as to the kt because we don't know what k is. We've got to go through and get that. All right, so what we do know is that there's another time of 10 where we have a value of 30. So we already know that we're going to be decaying. That tells me something about what k should be. And this was 10, so make that 10k. And then when we solve this, we're basically looking at a half-life setup. Okay, and then so I want to, in order to solve for k, I'm going to natural log both sides. Now here's where it gets a little bit funky, and your number 13 is going to do the same thing. We end up with 10k. Now remember that natural log of 1/2 is basically your division rule. So I don't know if you go back and remember your log rules. It says I can split that into natural log of 1 minus natural log of 2. And that's equal to 10k for right now. I know we're going to divide that 10 out. Well, natural log of 1 is just 0. So I actually have negative natural log of 2 equals 10k. Now I can divide by 10. And what they're doing, if you look at the answers here, what they're calling k is they're taking the negative 1 over 10 and calling that negative 0.1. And then leaving the natural log of 2. So this is actually what they're using for k. So when you go back to set up your answer, the answer actually looks like y of t is equal to the initial 60 e to the, and then it's just something funky like this. And that is how your final answer will look. So you're just kind of playing around with your log rules a little bit. Here's the rest of the homework assignment that I want to add as your part 2 of this. Again, you can just take pictures of it and send it to me, however that works for you. You can also paste it in OneNote, however you'd like to do that. And good luck. I hope I get to see you guys soon.